Assalamualaikum warahmatullahi wabarakatuh and welcome to my YouTube channel. So before I start, so make sure you have subscribe my channel and don't forget to like this video. So what we want to discuss today. So first look at this picture. So this is the picture of salt. Okay, this is the picture of table salt. So the first question that comes in our mind is what is the composition of this substance? Okay, what is the composition of this substance? Because we know that this is a table salt, so the composition of this substance is sodium and chlorine. So what is the IUPAC name of this substance? So that is what we want to discuss today. The IUPAC name of the table salt or and other salt. Okay. So the IUPAC nomenclature of salt. So hopefully at the end of this video, you are able to correctly name the salt. So what is salt? Salt is an ionic compound and that composed of cation and anion that bind together by ionic bond. What is IUPAC? So the letter IUPAC in the IUPAC is stand for International Union of Pure and Applied Chemistry. So I for international, U for union, P for pure, A for applied, C chemistry. So the IUPAC is the so what does IUPAC do? So it is the world authority on chemical nomenclature and terminology, including the naming of new elements in the periodic table, on standardized method for measurement, and on atomic weights, and many others critically evaluated data. So it is the authority that control the name of the chemical compound or element that have been found in this world. So what is the IUPAC name of salt? So it is the combination of the name of cation and anion in the salt. So when we know the name of cation and name of the anion, so we bind that together, so we will get the name of salt. First we go to the cation. So what is the cation? So cation is a positively net charged particle. It is formed when atom lost its electrons. So rules to name the cation. First rule is cation formed from metal atoms have the same name as the metal. Okay, cation formed from metal atoms have the same name as the metal. So we have three types of metal. Okay, first is the alkaline metal, which is in the group 1 particles, in group 1 elements, group 2 elements, group 30, some of the group 13 element, and the transition metal that is in the middle of our periodic table. So the cation that come from this metal atom has the same name as the metal. Let's say, for example, we have Na+. So Na+ come from element sodium. So the name of this ion is sodium ion. So we need to put the word ion at the end of the name because this is an ion. And then for the second example is Al3+. Al come from the aluminium element. So the name of this ion is aluminium ion. For Zn2+, this ion come from the element zinc. So the name is zinc ion. Second rule, if the metal can form cations with different charge, For example, that we have transition metal, the positive charge is indicated by a Roman numeral in parentheses followed by the name of the metal. Okay. For example, if we have Fe2 plus, okay, this rule is only applied for the metal, for the cation that have more than one charge. Okay, more than one charge. For example, this one, we have two charge of Fe. The first one is Fe2 plus, the second one is Fe3 plus. So for the first example, Fe2 plus, so we write the name is iron in the bracket Roman 2. So make sure there is no gap between the name of iron and the bracket. Okay, make sure there is no gap. So the name is iron 2 ion. So for this one, Fe3 plus, so the name is iron in the bracket Roman 3 ion. Okay, for the second example, we have Cu. Cu, we have two of, for this example, I give you two charge. The first one is Cu plus, the second one is Cu2 plus. So we name the Cu plus as copper in the bracket Roman 1 ion, and then for the Cu2 plus, copper in the bracket Roman 2 ion. So this condition is applied when the cation have more than one charge. Okay, one type of charge. Okay. And then the last rule is cation that is formed from non-metal atoms have name that end in IUM or IUM. Okay, for example, we have NH4 plus. NH4 plus is a non-metal atoms. So the name is this ion is come from the ammonia. So we just to form an ion, to form cation, it's add one hydrogen, so become NH4 plus. So the name from ammonia, it will change to ammonium ion. Okay, like this one, H3O plus. This one come from molecule of water, H2O, first one, and then it accept another one hydrogen, become H3O plus. This one we call as hydronium ion. Okay. And then this is the name of the common cation. So you may study the, this is just example of the common cation. So you may study and you may refer to my notes that I have give you earlier. So this one already there, already in the notes. So you may refer to the notes if you can't copy this table. Okay, this is the name of common cation. So you may use it to name the salt. Okay. And then we go to the second one, the second part of our salt, which is anion. So what is an ion? An ion is a negatively net charged particles. So it is formed when atoms receive electrons. So we know that electrons bring along the negative charge. So when atom receive electrons, so the negative charge will greater than the positive charge. That's why an ion has negatively net charge particles. Okay. So rule to name an ion, I have 5 actually. The first one is the name of monoatomic anions are formed by replacing the end of the name of the element with IDE or I. Okay, for example, we have H minus here. The name of this ion come from element hydrogen. So we convert the name of hydrogen into hydride ion. And then this one, N3 minus come from element nitrogen. So we change its name to nitride ion. And then this one, O2 minus. Okay, this one come from element oxygen. So we change its names to oxide ion. Okay, for the second rule, a few polyatomic anion also have name ending in "ide". Okay, just now I explained about the monoatomic anion. Mono means one. The anion is consists of one single atom. Okay, for polyatomic anions means that anion consists of more than one atom. For example, OH. Okay, OH. One is atom oxygen, the other one is atom hydrogen. So this one is OH minus. Okay, OH minus. So the name is hydroxide ion. And this one is Cn minus. One is carbon atom, the other one is nitrogen atom. So Cn minus, the name is cyanide ion. Okay, the third rule. Okay, the polyatomic anions once again. Okay, the polyatomic anions containing oxygen have name ending in either "ate" or "ide" and are called oxy-anion. So if our polyatomic anion containing oxygen, okay, has oxygen, the polyanion consists of oxygen, so the name will be ended with either "ate" or "ide", and this polyatomic anion that contain oxygen, we call it as oxy-anions. Okay, so for example, we have NO3 minus, so we call it as nitrate ion. So if we have NO2 minus, which is like one oxygen compared to nitrite, so the name will change to nitrite ion. Okay, same as this one, we have SO42 minus. This is a sulfate ion. So if the oxo and ion a lack of one oxygen, this one for the below compound is 3 oxygen, SO3 2 minus, we call it as sulfite ion. Okay. Okay, 4. Prefix are used when the series of oxy and ions. So oxy and ions once again. So prefix are used when the series of oxy and ion of an element extend to 4 members, as with the halogen. Okay, as with the halogens. So for example, we take the halogen for this example. So the prefix per, okay, the prefix per indicates one more oxygen atom than the oxy and ion ending in "ate". Okay, hypo indicates one oxygen atom fewer than oxy and ion ending in "ide". Okay, so let's explain this one. Okay, let's say we have ClO3 minus. Okay, ClO3 minus. So listen carefully. So ClO3 minus is chlorate ion. Okay, ClO2 minus is chloride ion because it has fewer oxygen, right, than chlorate. So it become chloride. Okay, how about this one? ClO4 minus. Okay, ClO4 minus contain more oxygen atom compared to chlorate ion. It more 1, right? So this one is 3, this one is 4. So instead of we use chlorate ion, so we change the name as perchlorate ion. It become per. So because the prefix per, okay, the prefix per used when the oxy and ion has one more oxygen atom than the oxy and ion ending in H. So we have oxy and ion ending is 8 here. Okay, ending in H here, chlorate ion. So this ion has one more oxygen atom. So the name become perchlorate. Okay, how about this one? ClO minus. Okay, so when we compare it with chloride ion, it is has fewer oxygen, right? For chloride, it has 2 oxygen, but this one it has 1 oxygen, so it has lost 1 oxygen, right? So we use this statement. Hypo indicates 1 oxygen atom fewer than oxy and ion ending in ITE. So for this one, ClO minus, it become hypochlorite ion. Okay, the prefix hypo here means that our chlorine has lost 1 oxygen compared to chloride ion. Okay, so listen, if you don't understand, make sure you just rewind this video. You need to listen it very carefully to understand these statements. Okay, the fifth rule to name the anion is an ion derived by adding H plus to to oxy and ion. Okay, once again, oxy and ion are named by adding as a prefix the word hydrogen or dihydrogen as appropriate. Okay, if the anion has adding H as heading hydrogen ion to an oxy and ion, so we will add a prefix hydrogen or dihydrogen, depends on how many hydrogen is being added. Okay, so for this one, H3O3 minus, so this one actually is come from carbonate, CO3 minus. Okay, CO3 minus has add CO3 2 minus has add H plus, so become H3O minus. So the name is, it has adding 1 hydrogen here, so it become hydrogen carbonate ion. So there is a space between each single word. Okay, each single word, hydrogen space carbonate space ion. Okay, how about this one? We have H2PO4 negative. So this one come from oxy and ion. PO4 3 minus, it has add 2 hydrogen ion, so become H2PO4 minus. So the name will be dihydrogen. Why di? Because we are adding 2 hydrogen. So 2 hydrogen means di. 2 means di. So dihydrogen, then phosphate, then ion. Okay, so this is name of common anion. So you may study the you may copy or study the this table. So I have give you some common anion here, so you may use it to name the salt after this. Okay, so for the exercise 1, for the first one is complete the table below by placing symbols and formula of cations and anions and name of ionic compound in the blanks. So the first one is cation or an anion for ammonium bromide. So you need to determine what is the cation and anion for the ammonium bromide. So you just write the symbol or the formula. Okay, for the second question, it asks you to write the anion only for barium sulfide. Has been given the cation for the barium sulfide. Okay, and then the third question, it blank the cation but give the anion for iron 3 chloride. You just write the symbol or the formula. And then for this one, it asks you to name the ionic compound when you have the cation is Pb2 plus and F minus. So what is the name of this ionic compound. Okay, that is exercise 1. And exercise 2, for each of the following compounds. Okay, first, we have NABr, PbSO4, CaOH2, and A3PO4, NH4, 2CO3. So first, you need to determine the cation and anion present in each compound. So you determine lah what is the cation and anion present in each compound. And then last, you name the compound. Okay. Exercise 3, give the formula for each of the following ionic compounds. So for this one, it gives you the ammonium carbonate. So what is the formula of the ionic compound? So make sure you write in your answer. Okay, so I think that's all for my video just now. So I hope that my explanation able to help you to understand how to give IUPAC name to salt. So see you in the next video. Assalamualaikum warahmatullahi wabarakatuh. Bye.